Welcome back to math class. Today our lesson exactly is talking about solving problems with ratios of fractions. Now, before we dig too much into what that means, let's take a look at our warm up. And today we have 4 problems. I want you to do number 1, number 2, and number 3. Remember that when we use the word product, we're talking about multiplication, and when we use the word quotient, we're talking about division. All right, pause the video and set a timer for 4 minutes, and let's do our warm up. The teacher will be checking for understanding while you are working. All right, you've hit play, which means you are ready to talk about the warm up. Remember, when we are multiplying or finding products of fractions, we multiply the numerator times the numerator and the denominator times the denominator. 1 times 3 is 3, and 2 times 5 is 10. 3/10 is what we have for number 1. Now, for problem number 2, you guys probably noticed something special. First of all, my people who like to simplify before they multiply probably noticed, hey, 8 cancels with 8 and 5 cancels with 5. So what's left? Before we talk about what's left, let's try it the long way. Now, if I solved this without any simplifying, what would I get? Let's see. I'd have 5 times 8, that's 40. I would have 8 times 5, that's 40, and that would give me 1. 40 over 40 is 1. Now, to answer the question that my people who simplified may have had, my 8 and my 8, when they cancel out, what do they actually become? 1s. My 5 and 5s do the same thing. So my canceling out crowd would also end up with 1. They would find 1 times 1 equals 1 in the numerator and 1 times 1 equals 1 in the denominator. However you do it, whether you multiply the 5 and the 8 and the 8 and the 5, or whether you simplify before you multiply, you will arrive at a product of 1. Now in our third example, we're asked to find a quotient. We have division. So before we multiply, we're actually going to rewrite this. Instead of 2/3 divided by 3/8, I want to write 2/3 times 8/3. To divide by, I hope you guys can't see that, can you? There we go. In order to divide by 3/8, I simply multiply by the reciprocal of 3/8. I multiply by 8/3. 2 times 8 is 16. And 3 times 3 is 9. This is a perfectly good answer, but most math teachers and most people in general probably prefer a mixed number to an improper fraction. So let's take this improper fraction and see how many times does 9 go into 16? Well, just once, right? With 7 left over? That means that this could be rewritten as 1 7/9. And the reason that number is a little bit easier for most people to understand is that just by looking at it, we can say, oh, 1 7/9. That's almost 2. It's just a very useful way of representing the number. Good job on the warm-up. Now that we're feeling warm and we're ready to go, let's look at today's learning goals. Our first goal is to compute unit rates. Now, we've computed unit rates before. The thing that makes today's goal new is we are going to be computing those unit rates from ratios of fractions. That means we'll have fractions in the numerator and in the denominator. We'll have fractions of fractions, and we'll be using that for length and area. Next, we'll be interpreting complex rates to solve real-world problems involving length and area. So we're getting into a little bit of geometry today too. Let's take a look at the next page in your book. Your instructions here tell you that ratios can be written using any numbers. A ratio in which one or both quantities being compared are written as fractions is called a complex ratio. So that's a new word for us today, a complex ratio. For example, Traveling 1/3 of a mile in half an hour represents a ratio of fractions or a complex ratio. It's also an example of rate, since the units being compared are different. Remember, a rate is just a ratio in which the units are different. So this ratio is a rate because it compares miles to hours. So we can write this ratio as a fraction. Here it is. 1/3 is in the denominator. Excuse me, 1/3 is in the numerator, and 1/2 is in the denominator. We have a fraction in our numerator, and we have a different fraction in our denominator. That is what makes this ratio complex. So our first task today is going to be working with complex ratios. And what we want to do is we want to rewrite each given rate as an equivalent ratio of fractions or as a complex ratio. Let's do the first example together. So part A here tells us that half an inch of rain fell in 15 minutes. So what are the units I'm comparing? I'm comparing inches to minutes. And specifically, we have 1/2 inch compared to 15 minutes. This is our complex ratio, 1/2 over 15. The entire fraction 1/2 is in the numerator. 15 is in the denominator. And that's all we have to do for number 1. All the instructions said to do was to rewrite it as an equivalent ratio of fractions. And we did that. So that's what this task is all about, using complex ratios to represent rates. Now, on the next example, we're going to have to think a little bit because we could just compare feet to minutes. Let's think about that. And feet to minutes would be 3,520 feet compared to 20 minutes. But you know what? That is not a complex ratio. It doesn't have a fraction in the numerator or in the denominator. But what if instead of knowing the number of feet in minutes, we wanted to know the number of feet in hours? So the feet per hour. Well, let's think about that. 20 minutes out of an hour. What fraction of an hour is represented by 20 minutes? Let's think about it. We have 20 minutes, and 1 hour has 60 minutes. So what fraction is that? What fraction would 20 minutes out of 60 minutes be? Well, let's see. Both my numerator and my denominator are divisible by 20. So I could actually write 20 minutes out of 60 is the same as 1 out of 3. If I want to write this ratio as a complex ratio, if I change my minutes to hours, I can have a fraction in my denominator. That will give me the complexity I was looking for. So let's try it now. Now I still have 3,520 feet, but in my denominator, I now have 1/3, because 1/3 of an hour is the same as 20 minutes. These two values, 20 minutes or 1/3 of an hour, those are exactly the same. That means these two ratios are the same. The one on the left is simple, and the one on the right is complex, but they both show the same value. Let's think about another example. Let's see. In the next one, in part C here, the baby gains 6 ounces every week. So here we're comparing ounces to weeks. 6 ounces every 1 week. 6 to 1. That's a simple ratio. There's not a fraction in the numerator or the denominator. One way to use this to write a complex ratio would be to use pounds instead. So what if instead of ounces, I wanted to see how many pounds the baby is gaining every week? In order to rewrite this as pounds to weeks, we need to know how many ounces there are in a pound. There are 16 ounces in 1 pound. So what fraction of a pound is the baby gaining every week? Well, that baby is gaining 6 16ths of a pound. 6 out of 16 pounds. And that's every week. Could we simplify that numerator? We sure could. 6 is divisible by 2. That's 3. And 16 is divisible by 2. That's 8. So we could say that the baby is gaining 3/8 of a pound every week. Now with a partner, I want you to try part D. Gas costs $2.50 per gallon. Work with your partner and find a complex ratio that you can write using that rate. Pause the video and set a timer for 2 minutes. Talk with your partner.